March 1, 1954, Bikini Atoll, the middle of the Pacific Ocean. American scientists were about to test a new weapon, a hydrogen bomb, a thermonuclear device. The calculations had been made. The yield would be 6 megatons, 400 times more powerful than Hiroshima, the largest explosion humanity had ever seen. The countdown began. 3, 2, 1. The blast was 2.5 times more powerful than expected. Not 6 megatons, 15 megatons. The mushroom cloud rose 80 kilometers into the sky. The fireball expanded to 6 kilometers wide. Part of Bikini Atoll vaporized. In its place remained a crater 2 kilometers across. But the real disaster began after the explosion. Radioactive fallout spread with the wind. It reached islands that were not in the calculations, and 160 kilometers away, a Japanese fishing boat was waiting for its fate. This is the story of Castle Bravo, the nuclear test that went catastrophically wrong. And how? American. Scientists' miscalculation poisoned an ocean, irradiated thousands of people, and changed the world's understanding of nuclear weapons forever. By 1954, the nuclear arms race was in full swing. The Soviet Union had tested its first atomic bomb in 1949, ending America's nuclear monopoly. Both superpowers were now racing to develop more powerful weapons. The next goal was thermonuclear bombs, weapons that used nuclear fusion rather than fission. Fusion bombs, also called hydrogen bombs, were theoretically far more powerful than fission bombs. While fission weapons were limited by the critical mass of their nuclear material, fusion weapons had no theoretical upper limit. You could make them as large as you wanted. The United States tested its first thermonuclear device, IV Mike, in November 1952. It had a yield of over 10 megatons, roughly 700 times more powerful than the Hiroshima bomb. But IV Mike was not a practical weapon. It weighed over 80 tons and required complex refrigeration equipment. The challenge was to create a deliverable hydrogen bomb, something that could fit on an aircraft or a missile, something that could actually be used in war. The scientists at Los Alamos National Laboratory developed a new design using lithium deuteride as the fusion fuel. This solid compound did not require refrigeration and was much lighter than the liquid deuterium used in IV Mike. The new bomb was called Shrimp. It was the first device in Operation Castle, a series of thermonuclear tests planned for early 1954. The test of Shrimp was codenamed Castle Bravo. It would become the most powerful nuclear explosion ever conducted by the United States, and it would become one of the worst nuclear disasters in history. The scientists made their predictions based on the physics they understood. Lithium deuteride contains 2 isotopes of lithium, lithium-6 and lithium-7. The scientists knew that lithium-6 participate in the fusion reaction, producing tritium that would fuse with deuterium. They assumed that lithium-7 would be inert. It would not contribute to the explosion. Based on this assumption, they calculated a yield of approximately 6 megatons. They were wrong. Under the extreme conditions inside a thermonuclear explosion, lithium-7 also undergoes nuclear reactions. It absorbs a neutron and produces tritium, just like lithium-6. The scientists had not anticipated this. The additional tritium from lithium-7 provided more fuel for fusion. Much more fuel. The yield was not 6 megatons, it was 15 megatons, 2.5 times greater than predicted. This miscalculation would have deadly consequences. The safety perimeters had been established based on a 6 megaton explosion. The fallout patterns had been predicted for a 6 megaton explosion. The evacuation zones had been calculated for a 6 megaton explosion. Everything was wrong, and by the time anyone realized it, the damage was already done. At 6:45 in the morning local time, Castle Bravo detonated. The fireball appeared instantly, expanding at incredible speed. Within seconds, it was nearly 7 kilometers in diameter, far larger than any previous nuclear explosion. The light was visible for hundreds of kilometers. Observers on ships 30 kilometers away felt the heat on their skin. The mushroom cloud rose with terrifying speed. It punched through the stratosphere and kept climbing. At its peak, it reached over 40 kilometers in altitude. The cloud eventually spread to a diameter of over 100 kilometers. On the surface, Bikini Atoll was transformed. The bomb had been placed on an artificial island in the lagoon. That island ceased to exist. In its place was a crater over 2 kilometers wide and 70 meters deep. Millions of tons of coral, sand, and seawater were vaporized by the explosion. This material was sucked up into the mushroom cloud, mixed with radioactive fission products, and began falling back to Earth as deadly fallout. The yield was so much greater than expected that the observation bunkers were nearly destroyed. Scientists and military personnel, who had thought they were at a safe distance, suddenly found themselves in danger. They hunkered down as the blast wave passed overhead, praying their shelters would hold. But they were the lucky ones. They had concrete bunkers. Others had no protection at all. The wind that day was blowing toward the east, not the northeast as predicted. This change in wind direction, combined with the unexpectedly large yield, sent the radioactive fallout in a direction that the planners had not anticipated. Instead of falling on empty ocean, the fallout drifted toward inhabited islands. Rongelap Atoll lay 160 kilometers east of Bikini. It was supposed to be safely outside the danger zone. It was not. Within hours of the explosion, white ash began falling on Rongelap. The 64 inhabitants of the atoll had no idea what it was. Some thought it was snow, though they had never seen snow before. Children played in it. Women brushed it from their hair. Men ignored it as they went about their work. The ash was intensely radioactive. It contained fission products from the explosion, including isotopes of strontium, cesium, and iodine. As it settled on skin, it caused burns. As it was inhaled, it lodged in lungs. As it contaminated food and water, it was ingested. By that evening, the people of Rongelap were experiencing acute radiation symptoms: nausea, vomiting, diarrhea. Their skin was burning and itching. Some reported a metallic taste in their mouths. But no evacuation came. Not that day, not the next. The United States did not evacuate Rongelap until 2 days after the explosion. For 48 hours, the islanders lived in a radioactive environment, continuously absorbing radiation from the fallout that covered their homes, their food, their water. 160 kilometers is a significant distance from a nuclear explosion. The Japanese fishing boat Daigo Fukuryu Maru, the Lucky Dragon 5, thought it was safe at that distance. It was not. The Lucky Dragon was a tuna fishing vessel with a crew of 23 men. On the morning of March 1st, they were fishing in the open Pacific, well outside the danger zone that the Americans had declared around Bikini. At 6:45 local time, the crew saw a strange glow on the western horizon. The sun seemed to be rising in the wrong direction. The light was orange and red, spreading across the sky. About 7 minutes later, they heard the sound, a deep rumble like distant thunder. They had just witnessed the Castle Bravo explosion from 160 kilometers away. The crew continued their work, not realizing the danger. Then, around 3 hours after the explosion, something began falling from the sky. It looked like white ash or snow. It settled on the deck, on the fishing equipment, the crew's hair and skin. One crew member reportedly tasted it and found it gritty and tasteless. The fallout fell for several hours. By the time it stopped, the Lucky Dragon was covered in a layer of radioactive ash. The crew, not understanding what had happened, collected their catch and began the 2-week journey back to Japan. During the voyage, they began to get sick. The symptoms appeared within days. First came the nausea and loss of appetite. Then the skin burns. The fallout had settled on exposed skin, causing radiation burns that resembled severe sunburn. The men's faces, hands, and necks were worst affected. Then their hair began falling out. By the time the Lucky Dragon reached its home port of Yaizu on March 14th, the crew was clearly suffering from radiation sickness. Japanese doctors immediately recognized the symptoms. The men were hospitalized, and their contaminated catch was seized. The Lucky Dragon's cargo of tuna, worth a small fortune, was too radioactive to eat. The case became an international sensation. Japanese newspapers ran headlines about American nuclear testing poisoning innocent fishermen. The public was outraged. This was the third time in 9 years that Japanese citizens had been victims of American nuclear weapons. All 23 crew members suffered from acute radiation syndrome. Their blood counts plummeted. Their immune systems collapsed. They required extensive medical treatment. On September 23, 1954, radio operator Eikichi Kuboyama died. He was 40 years old. His last words were reportedly, "I pray that I am the last victim of an atomic or hydrogen bomb." He was not. But his death made Castle Bravo an international incident that could not be ignored. The United States government responded to the disaster with denial and obfuscation. Initially, officials minimized the extent of the fallout. They claimed the Lucky Dragon had been inside the danger zone. They suggested the fishermen might be exaggerating their symptoms. They implied that the Japanese government was using the incident for political purposes. None of this was true. The Lucky Dragon had been well outside the declared danger zone. The crew's symptoms were consistent with severe radiation exposure. The fallout had spread far beyond what the Americans had anticipated or admitted. When Kuboyama died, American officials offered condolences but avoided accepting responsibility. They agreed to pay compensation, eventually settling for $2 million, but insisted this was not an admission of liability. The compensation was absurdly inadequate for the scale of the disaster. Thousands of people had been exposed to radiation. The Lucky Dragon crew was just the most visible example. More troubling was what the Americans did not reveal. Documents declassified decades later showed that officials knew the explosion had been far more powerful than expected almost immediately. They knew the fallout had spread to inhabited islands. They knew people were being exposed to dangerous levels of radiation, but they chose to downplay the disaster because revealing the truth would have created political problems. It would have raised questions about nuclear testing. It would have fueled opposition to nuclear weapons. It would have embarrassed the United States on the world stage. The cover-up continued for years. The full extent of the Castle Bravo disaster was not acknowledged until decades after the event. Perhaps the most disturbing aspect of Castle Bravo was what came after. The United States had accidentally irradiated the population of Rongelap and other Marshall Islands atolls. This was a tragedy. But some American officials saw it as an opportunity. Project 4.1 was a medical study of the radiation exposure suffered by the Marshall Islanders. It was initiated shortly after the Castle Bravo test. Officially, it was intended to monitor the health of the affected populations. In practice, it became something closer to a human experiment. The Marshallese people were not told the full extent of their exposure. They were not given adequate medical treatment. Instead, they were studied. American doctors recorded their symptoms, tracked the progression of their diseases, and compiled data on the effects of radiation exposure. The people of Rongelap were eventually evacuated from their atoll. But 3 years later, in 1957, they were returned to their island. The United States declared it safe to inhabit. It was not safe. Radiation levels remained elevated. The food and water were still contaminated. But the return of the Rongelap people allowed American scientists to study the long-term effects of living in a radioactive environment. For decades, the Marshall Islanders suffered elevated rates of cancer, particularly thyroid cancer. Birth defects increased. Miscarriages became more common. Children were born with developmental problems. The people of Rongelap did not know they were part of an experiment. They trusted the American government's assurances that their island was safe. That trust was betrayed. Castle Bravo's effects extended far beyond the Marshall Islands. The massive explosion had injected radioactive material high into the stratosphere. From there, it circled the globe, gradually descending and contaminating areas thousands of kilometers from the test site. Scientists around the world detected increased radiation levels in the weeks and months following the test. Radioactive isotopes appeared in rainwater in Europe, in soil in Asia, in food supplies on every continent. The global fallout was diluted across vast areas, so individual doses were small. But collectively, the exposure was significant. Scientists later estimated that Castle Bravo and subsequent nuclear tests contributed to thousands of cancer deaths worldwide. The test also contaminated the Pacific Ocean. Radioactive material settled into the water and entered the marine food chain. Fish accumulated radioactive isotopes in their flesh. The contamination spread far beyond the immediate test area. Japan was particularly affected. As an island nation dependent on seafood, Japan was vulnerable to contamination of fish stocks. The Castle Bravo fallout caused a panic in the Japanese fishing industry. Prices collapsed. Consumers refused to buy fish. The economic damage was substantial. The psychological impact was even greater. For Japanese people, Castle Bravo revived the trauma of Hiroshima and Nagasaki. Once again, American nuclear weapons had harmed innocent Japanese civilians. The anti-nuclear movement in Japan gained tremendous momentum. Castle Bravo made the world realize that nuclear weapons were not just tools of war. They were environmental catastrophes that affected everyone, combatants and civilians alike, for generations after the explosions. One unexpected consequence of Castle Bravo was cultural. In Japan, the Lucky Dragon incident sparked a wave of anti-nuclear sentiment. This anxiety found expression in popular culture, particularly in the film industry. Producer Tomoyuki Tanaka was on a flight back to Tokyo when he conceived of a movie inspired by the Castle Bravo disaster. He imagined a giant monster awakened from the deep by nuclear testing, a creature that embodied Japan's fears about the atomic age. The monster was called Gojira, a combination of the Japanese words for gorilla and whale. In the West, it would become known as Godzilla. The original 1954 film was not a simple monster movie. It was a meditation on nuclear terror. The opening scene directly referenced the Lucky Dragon incident, with a fishing boat destroyed by a mysterious flash of light. Throughout the film, the imagery of nuclear devastation, the burning cities, the hospitals full of radiation victims, echoed the horrors of Hiroshima and the fears raised by Castle Bravo. Godzilla became one of the most iconic monsters in cinema history. The character has appeared in dozens of films and become a global cultural phenomenon. But its origins lie in the very real terror created by the Castle Bravo test. The hydrogen bomb that was supposed to demonstrate American power instead created a lasting symbol of nuclear anxiety that has endured for 7 decades. Castle Bravo was a turning point in the nuclear age. The test demonstrated that thermonuclear weapons were even more dangerous than anyone had realized. The miscalculation that doubled the yield showed that scientists did not fully understand the physics of these weapons. The fallout that spread hundreds of kilometers proved that nuclear explosions could not be contained. Public opposition to nuclear testing increased dramatically after Castle Bravo. The Lucky Dragon incident and the contamination of the Marshall Islands became rallying points for anti-nuclear activists around the world. In 1958, the United States and Soviet Union began a moratorium on atmospheric nuclear testing. In 1963, the Limited Test Ban Treaty was signed, prohibiting nuclear tests in the atmosphere, underwater, and in outer space. Castle Bravo and its aftermath had helped create the political conditions for these agreements. For the people of the Marshall Islands, the legacy is more personal and more painful. Their islands were used as a nuclear testing ground without their meaningful consent. They were exposed to radiation, studied like laboratory subjects, and then largely forgotten. Compensation programs have never been adequate. Health problems continue to this day. Some islands remain uninhabitable. The Marshall Islands have become a symbol of the human cost of the nuclear age. Castle Bravo remains the largest nuclear explosion ever conducted by the United States. Its 15 megaton yield was 1,000 times greater than the Hiroshima bomb. It created a crater that can still be seen today in the waters of Bikini Atoll. And it demonstrated, in the most dramatic way possible, that nuclear weapons are not tools that can be precisely controlled. They are forces of nature that, once unleashed, cause destruction far beyond what their creators anticipate or intend. That is the lesson of Castle Bravo. A lesson written in radioactive ash across the Pacific. A lesson paid for by fishermen and islanders who never asked to be part of the nuclear age. A lesson the world is still learning today.